Have you ever found yourself pondering over the way machine learning algorithms group similar data? Well, it's your lucky day. Today, we're diving into the pool of knowledge to understand one such algorithm, known as K-medians clustering. Picture a bustling city, teeming with people from all walks of life. Now imagine trying to sort those individuals into groups based on certain common attributes, maybe their age, their occupation, or their interests. That's the essence of clustering, grouping objects that are similar to each other. Now you're probably wondering, what's this K-medians clustering? Well, it's a method of clustering. It's like the sibling of the more popular K-means clustering, but with a twist. It uses medians instead of means. Think about it this way. So you're trying to find the center of a group of numbers. If you were using the mean, you'd add up all the numbers and divide by the total count. But if you were using the median, you'd line up all the numbers and pick the one right in the middle. That's the key difference between K-means and K-medians clustering. K-medians clustering is excellent for when you have outliers or extreme values in your data. You know those pesky numbers that are way off the charts and can skew your results? The median isn't affected by those outliers, making it a reliable choice for such scenarios. But how does K-medians clustering work, you ask? In simple terms, it starts by randomly selecting K data points as the initial medians. Then each data point is assigned to the nearest median, forming clusters. The medians are recalculated for these new clusters. This process is repeated until the medians no longer change, and voila, you've got your clusters. To recap, K-medians. Clustering is a type of clustering algorithm that groups similar data together. It's like K-means clustering, but uses medians instead of means, making it less susceptible to outliers. The process involves randomly selecting initial medians, assigning data points to the nearest median, recalculating the medians, and repeating these steps until the medians stabilize. So the next time you're faced with a sea of data that needs to be grouped, remember K-medians clustering. It's like the unsung hero of machine learning algorithms, quietly and efficiently sorting data into meaningful clusters. It might just be the tool you need to make sense of the complex and fascinating world of data.